to right, the exponents of x are decreasing. So I just wrote here, I wrote it in standard form. And notice we have a polynomial here of degree 4. The leading coefficient's 1. This is actually the leading term, x to the 4. The constant term is 6. Okay, so that's one example with adding polynomials. Well, that's so much fun. So let's do another one. Are there any questions about this though, first? Okay. So again, it's the same idea. We want to add 2 together. And again, it just boils down to finding like terms and combining them. So we have these 2 like terms. Let me just actually, this might help a bit. So, okay, so we have 12x to the 5th, right? Are there any terms, any other terms, I should say, that are x to the 5th? Well, yeah, right here. We have 6x to the 5th. So what do? We're going to combine it with 12x to the 5th. Okay? Okay, so that's good. What about 4x to the 4? Okay, can we combine that with anything? Let's see, it looks like up here, we can combine it. When you combine it, don't forget the minus sign. Okay? You want to keep that with the term. That's what I'm doing here, as you can see. Okay. We have minus x cubed. Can we combine that with anything? It looks like no, so that we just leave alone. 9x squared. Can we combine that with anything? Yes, we can. We have an x squared here, see? We have 1. Can we combine that with anything? Oh, minus 10, that's all that's left. So we have that. So now we combine like terms. We have 12x to the 5th plus here, 6x to the 5th, 18x to the 5th. That's what we get here. 4x to the 4 minus 3x to the 4, right? That's just x to the 4. X cubed stays here. 9x squared plus x squared, that's 10x squared. Again, when you combine like terms, you add the coefficients or subtract them, depending on what you have to do. 1 minus 10 is minus 9. And so that's what we get. Well, 1 second. And this answer, as you can see, is in standard form, right? The powers of x the exponents are decreasing from left to right. Okay, someone had a question?
Yeah, in the final answer in the standard form part, right after the 10x squared, isn't there technically an x? Like if you were going to be dividing, you'd have to add the x.
We're not actually dividing here, but there's no x term though.
Oh, okay.
Okay. Okay. Good question though. Yeah, but there's no x term. I mean, I don't, unless I missed something, but I hope I didn't. Any other questions? Yeah. Someone had a question or? Oh, guess not. Okay. All right. Okay, so we have that. Right, so again, we don't have to put, there's no x term here. Right, okay. Now, that was horizontally. Again, if you want to stick with that method, that's fine. I just like to present more than one method because, you know, different methods can address different learning styles, because I know everyone has a different learning style. And I know when you add and subtract polynomials vertically, that's a little more visual. I do have the method here. And the basic idea, again, I'll demonstrate through an example. Basically, the first polynomial, you're going to have that. You're going to draw dashed columns for each term, and I would add zeros, intermediate zeros, that is, add zeros as intermediate placeholders. I personally like to do that to avoid confusion. And I have stuff here, but basically in the second polynomial, you're going to put like terms in the same column. And when you're adding, you're then just going to combine like terms. If you're subtracting, though, we'll see this later today, or if not the next time, you would distribute the minus sign and then add. Actually, no, you would distribute the minus sign, excuse me. And then it's good to write your answer in standard form. Again, I wrote the process here. It's really, you know, I feel like better demonstrated through example. Okay, so let me do that. And these are just some other things I put down I thought would be helpful. Again, here I kind of said it already. When you're subtracting, it's really good to distribute the minus sign before you combine. I mean, I've seen people, they would subtract and not distribute the minus sign. I mean, that's okay, but you do have to be a little bit careful. And with adding, I personally like to put the polynomial that has more terms as the one on top. I mean, do you have to do that? No, but personally, I like that better. If you use this method and you don't do that, that's fine. Okay, I don't want to go too fast. So if I go too fast, just let me know. But let's say, for instance, we want to add these two polynomials together. Okay, so this one has more terms, right? So I'm putting this as the one on top. And notice for each term, I'm making a column, a dash column, that is. Okay, so each term gets its own column. And now what's going to happen next? Well, this polynomial is going to go below it. Like terms, as you can see, go terms go in the column with their like terms. Like terms go in the same column. That's what I meant to say. Okay, like terms go in the same column.